Hello, how are you? How was your vacation? So today we are going to start our online class in mathematics. This is a lesson for Math M.2. So for our very first lesson, we are going to learn about exponential notation. Do you have any idea what exponential notation is? It's okay if you don't have any idea about it. So that's why we're going to learn it today. The exponential notation, it's very important to learn them because they can help us to write very small and very big numbers and make them simpler in their loops. So let's start with our definitions first. For example, I have here a times 10 raised to n. So what are these terms? What is a? What is 10? What is n? So 10 here is our base, n here is our exponent, and a here is any number. So this number should be greater or equal to 1, but less than 10. So this can be 9.8, this can be 7, this can be 1, this can be 1.2, but it can't be 10.5, 11.5, or 0.1. So those numbers are beyond our range, so we cannot use them. For example, 1.05, so it's still within the range, so we can use it. 0.98, no, we can't because it is less than 1 already. 11.78, this one is also not part of our range, so therefore we cannot use it. 8.27, yes, we can use it, so it is within our range. The exponential notation, the other terms for it are the following. We can also say scientific notation or standard form. They are all the same. So as you remember, we studied this one in our science class. The word scientific notation is the same as exponential notation. So whenever you see these two words or two sets of words, they are the same. I hope I made it clear for you. So let's move to the next lesson. For example, we have this number. Oh, it's a very, very big number, right? So as you can see, we do have 12 digits here. So we do have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. And the thing is, if we're going to write it down on a piece of paper, it's going to take a lot of time doing it. But how can we make it simpler? Now, that's the time we are going to use scientific notation or standard form. How to write it? First, just put a point at the very end of this number. Then we're going to move that point to the left. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so why did we move the point here? Our main purpose is to make this number more than 1 but less than 10. So this becomes 2.34. 2.34 is more than 1 and it is less than 10. So using this form, a times 10 raised to n, we can write a as 2.34 times 10, and the n here, we just have to remember how many times did you move the point. So in this case, we move it 11 times. So the thing is, if we're going to move the point to the left side, or going to the left, so that means we are going to use positive number. So this one is n equals 11. So the number here is 11. So that is positive 11. Now let's have another number. So this one is a very, 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 very small number. As you can see, we do have many zeros here, and we want to write it simpler. So how can we do it? Now we are going to use again this format, our scientific notation form or standard form, or our exponential notation. So how can we do it? So the same thing, all we have to do is to move the point, but this time we are going to move it to the right. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So remember, we move the point 13 times to the right. So our A is 1.23 times 10. Okay, always remember that we use times 10 here, always. So that is the standard format. So how many times did we move the point? So 13 times, but then the thing is, if we move it to the left, the answer here is positive. So therefore, the opposite of positive is, yes, you're right, it is negative. So therefore, our final answer is 1.23 times 10 raised to negative 13. Let's have another example. How about these numbers? They are all within our range. This one is more than 1 and less than 10. So this is fine. This one, 4.6. This is more than 1 and less than 10 also. Same thing with 9.27. So this one is more than 1 and less than 10 also. So how can we make or how can we write them in standard form or in exponential notation? So all we have to do is to remember this. A raised to 0 equals 1. Remember, any number raised to 0 is always equal to 1. And the thing is, 10 raised to 0 is the same as 1. So therefore, we can write this one as 3 times 1, and then we can substitute 1 with 10 raised to 0. So we have 3 times 10 raised to 0. So this one is the standard form of this number. The same thing happens here. 4.6 times 1 is the same as 4.6 times 10 raised to 0. Now for 9.27, that is times 1 also, which is equal to 9.27 times 10 raised to 0. So they are in the standard form now, or exponential notation, or you can also say scientific notation. They're all the same. So remember to write the whole numbers which are more than 1 and less than 10. You just have to multiply it by 10 raised to 0. So that is its standard format. Okay, let's move to the next slide. So this time, you are going to do this one. This is the test result section. So what I want you to do is to write the following numbers in exponential notation. As you can see, we do have 4 numbers here. The first one, we have 4,600,000. For B, we have 530,000. For C, we have 409,700,000. And D, we have 700,000. Just remember, what we are trying to find here is the standard format or the exponential notation of this number. So remember, this is always times 10 raised to something. So for number 2, we have write the following decimals using exponential notation. So here we do have very small numbers, which are all less than 1. So the first one is 0.00380. For B, we have 0.00004201. For C, we have 0.000063. And for D, we have 0.000000000089. That's a lot of zeros, right? That's why it's really important that we use exponential notations for these numbers. Okay, so let's do 1 and 2 first. So I'm going to solve A for you, and then you are going to do the rest. You are going to do B, C, and D. I'll show it to you. So for the first one, the answer is 4.6 times 10 raised to 6. How did they do it? So just put the point here and move to the left. 1, 2, 3, 4, 5, 6. So you have 6 as our exponent. As what I've said, the standard format is always times 10. So the answer here is 4.6, then multiply it by 10 raised to 6. So 4.6 times 10 raised to 6. So remember, we have so many ways to read this number. I can also read this one as 4.6 times 10 to the power of 6, or 4.6 times 10 raised to 6. And let's do letter B. The answer is 3.8 times 10. Now this one is negative 3. Now, why? Why did I do it? Because the thing is, we move the point here to the right. Remember, when you move the point to the right, it means negative to the exponent. The same thing with this one, the first one. When you move it to the left, so therefore it is positive. So here, we got 3.8. And then if we are going to move this point, let's just count it. 1, 2, 3. So the answer is 3. And what I've told you, you have to write negative here because we move it to the right. So 3.8 times 10 raised to negative 3, or 3.8 times 10 to the power negative 3. So number 3, it says convert the following numbers written using exponential notation into integer form. So when we say convert, means to say you have to change it. So convert means change in English. So exponential notation into integer form. The integer form is the usual number that we see. Same thing as this one. This is integer form. 530,000 is in integer. Same thing with 0.0000042001. It is in the decimal form. So we are going to find it by using this integer form. Integer form, they are whole numbers. So therefore, what we're trying to find here are whole numbers. So we are going to exclude. We're not going to include or put into consideration decimal or any number that has a point. So here we have to remove the point. So how can we do it? For example, we have 4.75 times 10 raised to 4. For B, we have 3.12 times 10 raised to 6. For C, we have 4.08 times 10 raised to 7. And for D, we have 9.81 times 10 raised to 3. So for letter A, I'm going to help you with that. So how can we do it? All we have to do is to move the point to the right. 1, 2, 3, 4. So just putting it in your mind and try to imagine how many points how many zeros we are going to add to this number. So 75 is already 2 digits, so we just have to add 2 more zeros. So in that case, this becomes 47,500. So do you know how to do letter B, C, and D now? Okay, I'm going to leave it to you to answer. For number 4, convert the following numbers written using exponential notation into decimals. Now remember this one, we have to convert them into decimals. That means we are going to use points here. Integer form doesn't have points, but decimals, they do. So for example, we have for A, 5.81 times 10 raised to negative 3. For B, we have 2.34 times 10 raised to negative 5. And for C, we have 9.0 times 10 raised to negative 6. And for D, we have 1.024 times 10 raised to negative 7. Now, have you noticed this one? So when we talk about decimals, and then if we are going to change them into exponential notation, the exponent is always in negative form. So it has always negative sign, the minus sign here, the negative sign. So therefore, all of this will become decimal. So how can we do it? So negative 3 means 3 places, moving the point 3 places. But what is the direction? Is it going to the left or going to the right? So as what I've said, negative means going to the right. So here, we are going to move it to make it as a decimal. So here, so going to the right when we move it, now let's do the opposite so that this one will become 0. So here, 1, 2, 3. So do you have any idea how it would look like? So I'll give you the answer. So the answer is 0.00581. What I did here is move it to the left, 1, 2, 3. So I needed 2 zeros before 5. So 0, 0, and then put the point here because it is a decimal number. And before the point, use 0. So it becomes 0.0058. This is very easy. What you have to do is to follow what I did in A. So you do it also to B, C, and D. So number 5, write the following numbers written using exponential notation. Remember, all these numbers, they are more than 1 but less than 10. So how do we do it? Remember, what we have to do is to multiply it by 1, and 1 is also the same as 10 raised to 0 because any number raised to 0 is 1. And why we use 10 raised to 0? Because that is the standard format of exponential notation. So for 8.31, the answer is 8.31 times 10 raised to 0. Very easy, right? So you are going to do the same for B, for C, and for D. So you are going to do the same thing for that. Okay. You have any question? So all of those things are quite easy to answer. So I'm going to leave them as your homework. So if you have any question, feel free to comment down below this video, and then I'm going to give you the answer of anything that I can help you. Okay, thank you so much, and see you again next time in our next online class. Goodbye and God bless.